Welcome aboard, guys. Hi again. My name is Angel. As you know, I'm a student of cybersecurity. I am always curious. I like to learn. I like to, especially when it comes to computers and cybersecurity IT stuff. I just love it. So right now, I'm going through the cybersecurity 101 learning path. The module that I will be completing right now is hashing basics. What I just wanted to say is that I just found out this because I was just checking. I kind of felt like I wanted to make some CTFs just to practice, to practice the basically the procedure when you go to do a pen test, right? Like to make reconnaissance, to exploit, you get a foothold, right? Then you leverage your privileges, and then um just basically do whatever you want with whatever it is at hand. Maybe that's a web app, where you can have access to the database, blah blah blah. So yeah, I was just checking this because I've never actually clicked on learn and then practice. So I click here, and then okay, yeah, there are learning paths, right? Because TryHackMe has been pushing some updates to its platform, and then I understand there's also cloud training, but I believe you have to pay extra for this. I'm not doing that just yet. So I was just checking the learning roadmap. No, I was besides the learning paths, I clicked on practice because I said, well, what's in practice? And then I found out that they basically suggest you some boxes based on your experience, right? So it's stock CTF. This is a CTF that I would do. Um, Crypto serialization, brief escalation, more, right? And then they basically give you a box and you have to capture the flags. That's something I would like to do. So yeah, I was just checking. Okay, so they do like recommend me some boxes based on my experience, right? My personal particular try hacking experience. I've completed plenty of learning paths here. So then there are some featured boxes. Expose your red teaming knowledge upon a Linux machine, blah blah blah. And then there's some of these boxes that are already completed by me. I think they should um well, this allow me to just filter them by, just only uncompleted boxes. But yeah, that's great. Still, there's a WordPress blog here. So yeah, I'm just fascinated by the amount of boxes TryHackMe has. Like this one's the one that I completed for the offensive pen testing learning path. So yeah, I still remember that. Then okay, but that's that. I just wanted to just get that out because I was just checking before I started the record. And yeah, also this is the general, right? And then they have some kind of series where, for instance, this WinCorp, this one caught my attention because the difficulty was insane, and that's sometimes I don't know. I've always been that kind of kid that likes to play. Even I used to play Resident Evil, and I used to enjoy when I would be able to just basically increase the difficulty to the max. So I like hard things, and this insane caught my attention. So if I click on enroll, it takes me to this particular WinCorp, and we try to make these boxes as lifelike as possible. So basically, there are four boxes here, right? And then they have this. So I was just uh, I liked it, right? I guess the correct way to go about this would be to finish first the easy ones, and then go to the medium, and then hard, and then insane, right? Because you don't want to get stuck, and especially me because I've recently been basically coming back to try hack me and doing CTFs. As you can see, there's this box pen testing tools which I already know about them, right? I've already completed them boxes, and then I was checking starters, and then the starter has some CTFs that I haven't done completed. So this could be helpful before I get to the WinCorp, right? But yeah, that's it so far. So what else? What else did I want to say? Yeah, basically just that. Of course, you can also, search for modules here. You can sort them by, I don't know, newest, and then the difficulty. Let's say I want to check the difficulty insane, and then you can see subscription type, only subscription, and then I have a series. Well, I guess this is the one from the previous boxes, right? The one that we checked out before. Yeah, the WinScorp. Yeah, right. That particular series here that we have. with core, right? And then here we have a series. Nice. All right, but that being said, let's get to business, right? We're here to do the hashing basics for now. So let's start. Okay. Hashing. Learn about hashing functions and their uses in password verifications and file integrity checking. Consider the scenario where you just downloaded a 6 gigabyte file and want to know whether the copy you downloaded is identical to the original file, bit for bit. How would you do that? Or if a good Samaritan handed you this 6 gigabyte file on a USB memory drive, how can you be sure it is identical to the file you wanted to download? That's a good question, right? The answer to both of the above questions lies in comparing the hash values of the two files. If two hash values are equal, you can say with very high certainty that the two files are identical. But what is a hash value? A hash value is a fixed size, string or characters that is computed by a hash function, right? A hash function takes an input of an arbitrary size and returns an output of fixed length, a hash value. We will cover various exciting and clever uses of hash functions and values in this room. Note about terminology. We favor the terms hash function and hash value. However, we occasionally use the word hash as a verb to mean calculate the hash value. Moreover, we occasionally use the word hash by itself as a noun to refer to the hash value. Okay? Room prerequisites. This room is the third of 3 introductory rooms about cryptography. Because we will reference the topics in the previous 2 rooms, it is recommended that you finish the last 2 rooms before attempting this one. I've already done that, so the learning objectives are: upon the completion of this room, you will learn about hash functions and collisions, the role of hashing in authentication systems, recognizing stored hash values, cracking hash values, the use of hashing for integrity protection, right? To follow along, first let's start the virtual machine by pressing the start machine button below. And then what? Then what? Uh, the machine will start in split screen view. In case the VM is not visible, use the blue show split view button at the top of the page. You can also access the virtual machine using SSH at the IP address. Yeah, that's the way I want to do it. That's the way I like to do things. Whenever they give me the possibility of just connecting, that's what I do. What? Why Rails? Well, it's page. This should be the VPN. Okay, so yeah, TryHackMe should open. And this is my VPN. I've already connected now. And now, if I ping this machine, which has already started, it's 10, 221, 71, just to check that we have no losses. Yeah, we are able to communicate with this box. So let's just SSH into it, right? SSH user and then 10, 71. And then yes. And then the password, which is TryHackMe. Made a mistake. I think TryHackMe123, and then this. And then we should be able to access that box. Yeah. Okay, so that being said, let's move forward. Hash functions. What is a hash function? Hash functions are different from encryption. There's no key, and it's meant to be impossible or computationally impractical to go from the output back to the input. A hash function takes some input data of any size and creates a summary or digest of that data. The output has fixed size. It's hard to predict the output for any input and vice versa. Good hashing algorithms will be relatively fast to compute and prohibitively slow to reverse. Go from the output and determine the input. Any slight change in the input data, even a single bit, should cause a significant change in the output. Let's check an example. In the terminal below, we can see 2 files. The first contains the letter T, while the second contains the letter U. If you check T and U in an ASCII table or using hexdump, you'll notice that the 2 letters differ by a single bit. The letter T is 54 and the letter U is 55 in hexadecimal both. And then in binary, they also differ. So consequently, the following 2 files differ by a single bit. However, if we compare their MD5 message digest algorithm file hashes, their SHA1 secure hash algorithm hashes, or their secure hash algorithm 256 hashes, we will notice that they are entirely different. We recommend that you try the commands below yourself. The files are located in Hashing Basics task 2. So if I go, what do we have? Hashing basics, and then task 2, and then what? Cat file and text. We got nothing here. Why? Okay, we got a T. You see? Okay. Now next is the cat file to text. A U, yeah, and then if I go hex dump, then minus C, and file 1, then we get their value, their ASCII value, and then the same one for these, but value file 2, we get their hex value, right? And now what you're asking me to do is md5 sum for the text files, and then it shows the hash value that's being encrypted using this particular algorithm. Okay, so the output of a hash function is typically raw bytes, which are then encoded. Common encodings are base64 or hexadecimal. Oh, they have been not encrypted but encoded, right? So our hexadecimal MD5 sum, yeah, okay, so these are producer outputs in hexadecimal format. Remember that hexadecimal format prints each raw byte as 2 hexadecimal digits. And now on to the next. Why is hashing important? Hashing plays a vital role in our daily use of the internet. Like other cryptographic functions, hashing remains hidden from the user. Hashing helps protect data's integrity and ensure passwords confidentiality. Consider this example of hashing being used to protect your cybersecurity. When you log into TryHackMe, the server uses hashing to verify your password. In fact, as per good security practices, a server does not record your password. It records the hash value of your password. Whenever you want to log in, it will calculate the hash value of the password you submitted with the recorded hash value. Similarly, when you log into your computer, hashing plays a role in verifying your password. You interact more indirectly with hashing than you would think, and almost daily in the context of passwords. What's a hash collision? A hash collision is when two different inputs give the same output. Hash functions are designed to avoid collisions as best as possible. Furthermore, hash functions are designed to prevent an attacker from being able to create or engineer a collision intentionally. However, because the number of inputs is practically unlimited and the number of possible outputs is limited, this leads to a pigeonhole effect. As a numeric example, if a hash function produces a 4-bit hash value, we only have 16 different hash values, right? The total number of possible hash values is 2 number of bit to the number of bits to the 4. Okay, and would be 16. The probability of a collision is relatively very high. The pigeonhole effect states that the number of items, pigeons, is more than the number of containers, pigeonholes. Some containers must hold more than one item. In other words, in this context, there are a fixed number of different output values for the hash function, but you can give it any size input. As there are more inputs than outputs, some inputs must inevitably give the same output. If you have 21 pigeons and 16 pigeonholes, some of the pigeons are going to share the pigeonholes. Consequently, collisions are unavoidable. However, a good hash function ensures that the probability of a collision is negligible. MD5 and SHA1 have been attacked and are now considered insecure due to the ability to engineer hash collisions. However, no attack has yet given a collision in both algorithms simultaneously. So if you compare the MD5 and the SHA1 hash, you will see that they're different. You can view the MD5 collision example on the MD5 collision demo page. Furthermore, you can read the details of the SHA1 collision attack at Shattered. Due to this, you shouldn't trust either algorithm for hashing password or data. Okay, what is SSH256 hash of the passport? Okay, so hex, no, that would be, I guess, SSH256. Would I be able to do that? I'm not sure, because I was able to MD5 some. Oh, so it would be SHA256 some. Yeah, okay, that's the command. And then hash of the passport, and where is that? File in hashing basics task 2, passport, yeah. I believe we got it. Okay, let's copy that hash, submit it, and yeah, we got the, what is the output size output size in bytes of the MD5 hash functions? MD5 hash functions. Oh, those were like, but we are asking me what is the output size in bytes. I'm going to figure that out. What is the output size in bytes? Count the number of hexadecimal digits and divide by 2. The number of hexadecimal digits and divide them by 2. Okay. So MD5 sum .txt, which is a command that we ran before, and then I have to count the number of hexadecimal digits. Okay, I mean, I don't have Ruby installed. I don't have Ruby installed. I should, because that's the language that I use for scripting. But okay, um, let's say. So how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, just string counter. Online character count tool, yeah, basically. Start typing. How many do we have? It's one word, 32 characters, right? So divided by 2 would be 16. I just used an app that counted strings and counted the characters that I have there. So then again, if you have an 8-bit hash output, how many possible hash values are there? If you have an 8-bit hash output, how many possible hash values are there? Well, if we had 4, I think we had an example here, right? If a hash function produces a 4-bit hash value, which in this case would be 8, so it would be 2 to the 8. That would be 32, 32, then 64, then 128, and then 256, right? 256. Yeah, insecure password storage. For authentication. Okay, hashing has many uses in cybersecurity. In this room, we will focus on 2 uses, password storage and data integrity. We refer to password storage when used for authentication. Yeah, it is important to note that this does not apply to password managers, where you must retrieve your password in clear text. On the other hand, authentication mechanisms only need to confirm that the user knows the password, so they can be granted access to the resource. Therefore, this problem differs from password managers. Stories of insecure password storage for authentication. Most web applications need to verify a user's passwords at some point. Storing these passwords in plain text is a very insecure security practice. You've probably seen news stories about companies that have had their database leaked. Knowing that many people use the same password on their various accounts, including their online banking, leaking the password from one account jeopardizes the security of all the other accounts. We will visit 3 insecure practices when it comes to passwords. Storing passwords in plain text, yeah, we know what that. Storing passwords using a deprecated encryption, yeah, no go. Storing passwords using an insecure hashing algorithm, right? Yeah, we don't want that. Storing password in plain text, this has to be like bananas. How could you do that? Quite a few data breaches have leaked plain text passwords. You're probably familiar with the RockU tags, password list on Canada Linux. Yeah, this is a word list that you can use to basically brute force many authentication services with some words that were previously leaked, I understand, right? Among many other offensive security distributions, this password list came from RockU, a company that develops social media applications and widgets. They stored their passwords in plain text, and the company had a data breach. The text file contains over 14 million passwords. You can find RockU at user shared word list directory, right? Yeah, using insecure encryption algorithm. Adobe's notable data breach was slightly different. Instead of using a secure hashing function to store the hash values of the passwords, the company used a deprecated encryption format. Furthermore, password hints were stored in plain text, sometimes containing the password itself. Consequently, the plaintext password could be retrieved relatively quickly using an insecure hash function. LinkedIn also suffered that data breach in 2012. LinkedIn used an insecure hashing algorithm, the SHA-1, to store passwords, user passwords. Furthermore, no password salting was used. Password salting refers to adding a salt, a random value to the password before it is hashed. Why? Why would that happen? That's weird. That's never happened to me before. Let's keep going. What is the 20th password in RockU? Okay. So where do we have that? Have rock. Oh, share. No, it's user. Share word list. RockU. Is there a way to actually what? What's going on? Shouldn't be happening. I've never had this problem. Let's just reload the page. And then since you terminated my machine, I want to start one again. If you terminate it again, I will be pissed. Okay, so now that's starting. Insecure password. Yeah. Okay, what did you ask? What is the 20th password in RockQ? Yeah, right. I was just checking if RockQ, if the head command would allow to print a first n. Okay, so that's what I want. So I want minus n and then the first 20, right? If they're asking me for the 20th, it would be QWERTY. QWERTY. Okay, up to the next. Using hashing for secure password storage. Using hashing to store passwords. This is where hashing comes in. What if instead of storing the password, you just store its hash value using a secure hashing function? This process means you never have to store the user's password, and if your database is leaked, an attacker will have to crack each password to find out what the password was. There's just one problem with this. What if the users have the same password? As a hash function will always turn the same input into the same output, you will store the same password to hash for each user. That means if someone cracks that hash, they gain access to more than one account. It also means sometimes someone can create a rainbow table to break the hashes. A rainbow table is a lookup table of hashes or to plain text, so you can quickly find out what password a user had just from the hash. A rainbow table portrays the time to crack a hash for hard disk space, but it takes time to create. Here's a quick example to get an idea of what a rainbow table looks like. Which is bananas. I don't know why this is happening. I'm just trying to go to the machine. Come on. Oh, sorry, we're here checking on this. Websites like CrackStation and Hashes.com internally use massive rainbow tables to provide fast password cracking for hashes without salts. Doing a lookup in a sorted list of hashes is quicker than trying to crack the hash. Now, protecting against rainbow tables. To protect against rainbow tables, we add a salt to the passwords. The salt is a randomly generated value stored in the database and should be unique to each user. In theory, you could use the same salt for all users, but duplicate passwords would still have the same hash and rainbow table could still be created. Okay. Could still be created for passwords with that salt. The salt is added to either the start or the end of the password before it's hashed. And this means that every user will have a different password hash even if they have the same password. Hash functions like bcrypt and scrypt handle this automatically. Salts don't need to be kept private. Example of securely storing passwords. You can find many good guides online that promote best security practices when storing passwords. Please check if there are any standards you need to follow when storing passwords before adopting one. Consider this example following good security practices when storing user passwords. We select a secure hashing function such as Argon2, Script, Bcrypt, or PBKDF2. We add a unique sound to the password such as this. Concatenate the password with a unique salt. For example, if the password is this one, the result string would be that plus this, right? And then calculate the hash value of the combined password and salt. In this example, using the chosen algorithm, you need to calculate the hash value of this. Store the hash value and the unique salt used. Using encryption to store passwords. Considering the problem of saving passwords for authentication, why don't we encrypt passwords instead of all these cumbersome steps? The reason is that even if we select a secure hashing algorithm to encrypt the password before storing them, we still need to store the used key. Consequently, if someone gets the key, they can easily decrypt all the passwords. So manually check using the rainbow table above. And it's this, right? Then crack the hash. So they did provide us with some tools. I'm gonna just take note of these tools because I've been uh, rainbow tables, right? Okay. Okay, hashing tools. We have the crack station and hashes.com, right? And then what I want to do is just copy the link, and then I want to cut this link, and then here as well, copy the link. Okay, so if we go to, let's go to crackstation.net, and then they're asking us for this particular hash using an online tool, which is this one. I'm not a robot, am I? And now we get unrecognized hash format. By crack the hash. Okay, let's just go to the next tool, which is hashes.com. Copy and then decrypt this submit WN DTQ7 DT. Oh, it was JT and WNGKCS hash identifier. Could not identify. But what is going on? Crack the hash. Crack hashes. No, not found. I'm not a robot. Crack it. Still unknown. I don't know. Search again. And it finds like no hashes using this tool. This page will tell you what type of hash was giving the string. Giving a string is. If you want to attempt to crypt them, click this link instead. Yeah, that's what I want. Okay, NER78G. Oh, found. Let's try hack me. What a surprise. Should you encrypt passwords in password verification systems? Encrypt them? No, because it's unsafe. If someone gets the key, as I said, they have access to all the passwords. We don't want that. So hashing comes in handy here. Recognizing password hashes. From the cyber defensive security perspective, we covered how to store passwords securely for authentication systems. Let's tackle this from the offensive security perspective. If we start with a hash, how can we recognize its type, eventually crack it, and recover the original password? Automate the hash recognition tools such as hash ID. Okay, another tool. Exist but are unreliable for many formats. For hashes that have a prefix, the tools are reliable. Use a healthy combination of context and tools. If you find a hash in a web application database, it's more likely to be MD5 than NTLM, NT-Line Manager. Automated hash recognition tools often get these hash types mixed up, highlighting the importance of learning yourself. Linux passwords. On Linux, password hashes are stored in EDC shadow. What? Cannot access? It's TryHackMe 123, and then user is not in the sudoers file. Okay. Hash are stored in this particular folder, which is normally only readable by root. They used to be stored in EC pass WD, which was readable by everyone. Okay, the shadow file contains the password information. Each line contains 9 fields separated by columns. The first 2 fields. Let's just check my box here, and then sudo plus shadow, not a directory. Okay. Oh, what? It's not a directory. Okay, maybe it's a file, right? So cat sudo cat um oh yeah, okay, makes sense. So we have them. Each line contains 9 fields. Uh-huh. Uh, Separated by columns. The first 2 fields are the login name and the encrypted password. Login name and then the encrypted password. This is the encrypted password in this case. Galeta, yeah, Redis. Okay. More information about the other fields can be found by executing man5 shadow on a Linux system. The encrypted password field contains the hash passphrase with 4 components: prefix, algorithm ID, options, parameter, which are the parameters, the salt, and hash. It is saved in the format of prefix, options, salt, and then the hash. Okay. The prefix makes it easy to recognize Unix and Linux style passwords. It specifies the hashing algorithm used to generate the hash. Here's a quick table of some of the most common Unix style passwords prefixes you might encounter. They are listed in the order of decreasing strength. You can read more about them by checking the man page with man5 crypt. Okay, yes, crypt is a scalable hashing scheme, and it is the default and recommended choice in new systems. And then Ghost script uses the Ghost R34 hash function and the script hashing method. Script is a password-based key derivation function, and I guess these are all also just hashing algorithms. Modern Linux example. Consider the following line from a modern Linux system shadow password file. Strategos. The fields are separated by columns. The important ones are the username and the hash algorithm, salt, hash value. The second file has the format of prefix, options, salt, hash. Yeah. In this example above, we have 4 parts separated by this dollar sign or symbol. Y indicates the hash algorithm used, the script, this, right? And then J90 is a parameter passed to the algorithm. And then this is the salt used. And then this is the hash value, right? Source from here. Okay, MS Windows passwords. MS Windows passwords are hashed using NTLM, a variant of MD4. They're visually identical to MD4 and MD5 hashes, so it's very important to use context to determine the hash type. On MS Windows, password hashes are stored in the SAM, Security Accounts Manager. MS Windows tries to prevent normal users from dumping them, but tools like Mimkatz exist to circumvent MS Windows security. Notably, the hashes found there are split into NT hashes and LM hashes. A great place to find more hash formats and password prefixes is in the hashcat example hashes page. For other hash types, you'll typically need to check the length or encoding or even conduct some research into the application that generated them. Never underestimate the power of research. What is the hash size in a script? The hash size, that would be research online or check the manual page. 1 5 script. Maximum hash size 256 bits. 256 bits. Was the hash mode listed for Cisco? Check the hashcat example hashes page. Okay, well, we're looking for the hash mode listed for Cisco, right? Cisco ASA. And you're asking me for the hash mode. O2. What is the hash mode? Oh, okay. This is the hash mode. 2410. Okay. What hashing algorithm is used in Cisco iOS if it starts with well, if it starts with that? Oh, I don't have that here. Maybe what's the question? What's the hashing algorithm used? Script. Yeah, okay, password cracking. Okay. We have already mentioned rainbow tables as a method to crack hashes that don't use salt, but what if there's a salt involved? You can't decrypt password hashes. They're not encrypted. You have to crack the hashes by hashing many different inputs, such as rock text, as it covers many possible passwords, potentially adding the salt if there is one, and comparing it to the target hash. Once it matches, you know what the password was. Tools like Hashcat and John the Ripper are commonly used for these purposes. Cracking passwords with GPUs, right? Modern GPUs, graphic processing units, have thousands of cores. They are specialized in digital image processing and accelerated computer graphics. Although they can't do the same sort of work that a CPU can, they are very good at some mathematical calculations involved in hash functions. You can use a graphics card to crack many hash types and quickly. Some hashing algorithms, such as bcrypt, are designed so that hashing on a GPU does not provide any speed improvement over using a CPU. This helps them resist cracking. Cracking on VMs, it's worth mentioning that VMs, virtual machines, normally don't have access to the host graphics card. Depending on the virtualization software you're using, you can set this up, but it's cumbersome. Furthermore, performance degradation occurs as you use the CPU from a virtualized OS. And when your purpose is to crack a hash, you need every extra CPU cycle. If you want to run a hashcat, it's best to run it on your host to make the most of your GPU if available. If you prefer, okay, this is something important. If you want to run hashcat, it's best to run it on your host machine, not in the virtual machine, right? To make the most of your GPU. Okay, if you prefer MS Windows, you're in luck. MS Windows builds are available on the website, and you can run it from PowerShell. You can get hashcat working with OpenCL in a VM, but the speeds will likely be worse than cracking on your host. John the Ripper uses CPU by default and works in a VM out of the box, although you may get better speeds running it on the host OS. Uh-huh. To avoid any virtualization overhead and make the most of your CPU cores and threads. Time to crack some hashes. I provide the hashes, crack them, you can choose how. You'll need to use online tools like Hashcat, copy link. Then the other one is John the Ripper. Although you can use online rainbow tables to solve the following, you strongly advise against doing that, as this will restrict your learning experience. Okay, for the first three questions, using Hashcat along with RockU is enough to find the answers. Okay, Hashcat along with RockU, right? So let's just check if I have Hashcat command not found. Well, what I want to do is install it, right? Should I download the binaries? Oh, I can install just using sudo apt install. Okay, I'm installing Hashcat on my host machine. And then we're gonna be just cracking the first three, and then we will move on reading for the next, right? They do mention that I can use Hashcat is enough to find the answers for the first three questions, right? Already. So I already have that Hashcat. And now, what do you want me to crack? Oh yeah, but do I also have the shared word list? I don't have the word list here. Hmm. Okay. Oh yeah. Okay. So I have just okay. The sec lists, right? So install to complete. Uh, so what I want to do is just where am I? And then git clone here. And then I'm cloning the complete word lists to my machine. This should take a bit. Okay. So how's the hash gonna work? So if I go hashcat and then that's six hash basics and then that's six and then hash1.txt. What is it gonna be? To detecting hash, please specify a hash mode with minus n. For example, minus n to 1000 is for until man hashcat. Let's just say 0. Now hash is loaded. example, A series for straight. Try one password from the word list after another. Yeah, that's what I want, but I also did not specify the word list, right? So what am I even doing? -8 and then 0 and then hash file is the file containing the hash you want to crack, which is this one. And then I should specify the word list, right? User shared word lists, and then rock you. We'll treat the hashes by crypt and try the password in the rock you. 32. Yeah, okay. No hash is loaded. What am I doing wrong? Big hash cat -m, and let's push it for 32, and then -a 0 hash, no, not hash. I want to go to this particular hashing basics -6, and then #1. Okay, looks like it's doing something now. Sorry, attacking STD mode. Okay. Oh yeah, I guess we can check what type of hash it is by just checking at this particular thingy. Like it does say $2A and then dollar. That is $2A. This is a bcrypt. So if I want to use bcrypt, oh yeah, that's the one I'm using. So it should give me the response. Yeah. Okay. As far as my own computer, it's still downloading my main OS is still downloading the SAC lists to my machine. So okay, what do we have? No password candidates. What? That's bollocks. Oh, zero. It's for straight trying one password from the word list after another, which is what I wanted, right? And then just specify the hash file, and then you also have to specify the user shared word lists, and then drop you. Did I not provide the word list before? It's weird. Initializing back in runtime for blah blah blah. Calls memory required. Oh, status post bypass checkpoint finish grid. Okay. This can cause your screen to lag. Yes. Okay, did you find it? Session cracked. Digest 101 pure kernel. What is the word? Candidates number 1. Okay, I think that's the one, right? So it should be this one. Okay, yeah. Use again to crack the SSH 2256. SSH8256. And then, oh, it's 2256. Okay, so this one is this one. Let's see. So I just have to copy this. Then I have to change this particular number. Not this. 34220. Okay, and then what hash? It's the hash number 2. Same task, and then use that same what. Can I make sure object file such file or directory? hash2.txt. Okay, hash got to grab this particular hash. 256. Alright. Maybe it's this one. Okay, looks like that's working. Okay, the hash got, yeah, sure. But, okay. So, sure, passwords. Where's Rock here? Bible books. Media. Here. Oh, here. Passwords leaked that databases. Okay, so we can just go here. Did it finish? Oh, Halloween. Halloween. Okay, use hashcat to crack the hash. This particular hash. 6. What the? Yeah, it's 1800s. And then it's also the hash 2. No, it's a hash number 3. Okay. This should give me that particular. And then the last one, crack the hash saved in the hash 4. And this hash, I would assume it's the first one, right? Like the first type of hash, which is 75. So if I go, it's 0, I think. or 10. No, I don't think so. Salt. This one is just as long. So, okay. Okay. This takes a bit of time, but that's alright. Leaked databases. Find it. So let's hash again. Then we have to specify -m. I guess it would be the number 0, right? And then I want to specify the attack. It's gonna be just -a 0. Then we specify the hash. Then what we want to use to crack this particular hash, I guess it would be, let's assume that it's gonna be checklists of passwords. Passwords in the databases, and then raw queue. How to tell which one to use? Raw queue 5, let's say. Initializing background time for the rest of the world. Please be patient. Did you find it? Monkey. Oh, I think it is this one. Yeah, it's not. Why do you give me monkey? 1, 2, 3, 4, 5, 6. Is that it? No. 1, 2, 3. That makes no sense. Too small. Okay, here we got spaceman, and then the hash for this one. You will need to use an online service. Okay. Which service would I use? Search again. Hashes 5M6HC8. Oh, found. Fun for you. Yeah. Okay. That's it. We got all the hashes. Now, on to the next. Hashing for integrity checking. So in task 3, we mentioned that we would focus on 2 uses of hashing, password storage and data integrity. We have extensively discussed how hashing secures passwords in an authentication systems. In authentication systems, in this task, we will discuss how we can use hash functions to check the integrity of files. Integrity checking. Hashing can be used to check that files haven't been changed. If you put the same data in, you always get the same data out, even if a single bit changes. The hash will change significantly as demonstrated in task 2. This means you can use it to check that files haven't been modified or to ensure that the file you downloaded is identical to the file on the web server. The text file listed below shows the SSH256 hash of 2 Fedora Workstation ISO files. If running SHA-256 on the file you downloaded return the same hash listed in this signed file, you can be confident that your file is identical to the official one. Okay? You can also use hashing to find duplicate files. If 2 documents have the same hash, they are the same document. This is very convenient for finding and deleting duplicate files. HMAC. Okay, yeah, it is. HMAC key hash message authentication code is a type of message authentication code that that uses a cryptographic hash function in combination with a secret key to verify the authenticity and integrity of data. Okay. An HMAC can be used to ensure that the person who created the HMAC is who they say they are. Authenticity is confirmed. Moreover, it proves that the message hasn't been modified or corrupted. Integrity is maintained. This is achieved through the use of a secret key to prove authenticity and a hashing algorithm to produce a hash and prove integrity. The following steps give you a fair idea of how HMAC works. The secret key is padded to the block size of the hash function. The padded key is XO red with a constant, usually a block of zeros or ones. The message is hashed until the hash function with the XO red key. The result from step 3 is then hashed again with the same hash function but using the padded key, okay, with another constant. The final output is the HMAC value, typically a fixed size string. The illustration below should clarify the above. The secret key is padded. This is the key. It's padded to the block size of the hash function. Okay. The padded key is XORed with a constant. Usually a block of zeros or ones. The message is hashed using the hash function with an XOR or key. Yeah, the result from step 3 is then hashed again with the same hash function but using the padded key. Yeah, okay. Okay, technically speaking, the HMAC function is calculated using the following expression. Note that M and K represent the message and the key respectively. What is SSH hash for this fountain? Okay, so it would be SHA-256 some, right? And then we want to go to hashing basics task 7, and then your lib. We got this key. What's the hashcat mode number? Or HMAC minus. I don't know what I just wanted to do that. What's the hashcat mode number? It's this one. Yeah, and then the conclusion. This room covered hashing functions and their uses from various perspectives. Before moving on, we should uh, sorry, we should distinguish between hashing, encoding, and encryption. Okay, hashing, as already stated, is a process that takes input data and produces a hash value. A fixed size string of characters, also referred to as digest. This hash value uniquely represents the data, and any change in the data, no matter how small, should lead to a change in the hash value. Hashing should not be confused with encryption or encoding. Hashing is one way, and you can reverse the process to get the original data. Encoding, however, converts data from one form to another to make it compatible with a specific system. ASCII, UTF-8, and blah blah blah. Okay, and Windows 1252 are valid encoding methods for the English language. Note that UTF -8 and 1632 are Unicode encodings, and they can represent characters from other languages, such as Arabic and Japanese. Another type of encoding commonly used when sending or saving data is not for any specific language. Examples include base 32, base 64 encoding. Consider the following example of using base 64 to encode and decode. Base 64, TryHackMe, and then base decode. Encoding should not be confused with encryption, as using a specific encoding does not protect the confidentiality of the message. Encoding is reversible. Anyone can change the data encoding with the right tools. Only encryption, which we covered in the previous rooms, protects data confidentiality using a cryptographic cipher and a key. Encryption is reversible, provided we know the cipher and can access the key. To continue with this module, join the Reaper. However, if you would like to gain more in-depth information about cryptography, consider this room that dives into more concepts. Cryptography intro. Already finished that. And showcases more tools related to cryptography. Use base 64 to decode this. Okay. No. Minus D, and then this. What the heck? base 64 minus D, and then no such file or directory. What was the command that you used? Okay, I guess it's minus D. And then are you prompted for something? Yes, this. Now what? Saved us. Okay. Okay. Let's just show split view. Then let's go through that. So base 64 minus D, and then we want to specify what. So it will be hashing basics, then task 8, and then decode this, encode, decode. Okay, I'm sure you have noted the various concepts and tools explored in this room. I have. Okay, that was it with me, guys. This was the hashing basics. TryHackMe room. The machine was giving some issues, right? It was terminating itself. But yeah, so far we managed to conclude the room. 20 days ago, this room was created. Yeah, that's it, guys. Uh, I'll see you in the next one. Peace.